Number 44. Correct the following statement. The bonds in solid PbCl2 are ionic. The bond in an HCl molecule is covalent. Thus, all the valence electrons in PbCl2 are located on the Cl- ions, and all of the valence electrons in an HCl molecule are shared between the H and Cl atoms. Okay, so we just have to run through the statement and pick out what is wrong with it. Now, the first part that I see where they talk about the bonds in solid PbCl2 are ionic, that's totally correct. Why? Because if I drew out PbCl2, let's see what type of compound this is. Pb is lead, and Cl is chlorine. And lead is over here on the periodic table. Pb is all the way down here, and that's a metal. Chlorine is over here, and that's a nonmetal. You see the difference in the colors? So lead is a metal, and chlorine is a nonmetal. So in this compound, we have a metal and a nonmetal, and therefore this is ionic. So this is correct. The first part is correct. I don't see anything wrong with that part. The second part where they say the bond in the HCl molecule is covalent, that's also a correct statement, because if we see HCl, hydrogen is a nonmetal, it's over here, and chlorine is also a nonmetal. Covalent compounds exist when you have two or more nonmetals coming together. Since HCl, hydrogen and chlorine are both nonmetals, so we have two nonmetals, this would be a covalent compound or a covalent molecule. Remember, you can never say molecules for ionic compounds. You can only say molecule for covalent. So now there's probably going to be a problem with the second part. So let's look at it. When they say thus, all, okay, so that's a big statement right there, right? They say all of the valence electrons in PbCl2 are located on the Cl- ions. So if we drew this out, they're telling us that all of the valence electrons should be located on the Cl-. So let's draw it out. So when we talk about ionic, we talk about transfer of electrons, right? And remember, covalent is sharing electrons. So in ionic, you won't see the single bond, double bond, triple bond. That's only in covalent compounds. In this case, you'll just see electrons being thrown from the metal to the nonmetal. So if I drew out Pb, and now I have two Cl's, right? And how many valence electrons are on lead? Well, lead's over here. It's in group 14, and we should know the groups, and we should know the trends, right? Group 14 always has 4 valence electrons. Remember this trend. Hydrogen has 1, and then from 13 all the way to 18, it's 3, 4, 5, 6, 7, and 8 valence electrons. So Pb has 4 valence. So I will just draw 4 dots around Pb. 1, 2, 3, and 4. And then each chlorine's over here, each chlorine has 7. So I'm going to draw 7 around chlorine. So 1, 2, 3, 4, 5, 6, and 7. And the same thing for this one. Now, if it's ionic, that means that there should be a charge, right? And we should know what ion lost electron and what ion gained electron. And remember, we do the crisscross method, right? So we could crisscross the subscripts back up to find out the charges. There was 1 Pb here. There was 2 chlorines here. This 2 crisscrosses back up to tell me that Pb was a +2 charge. And this 1 crisscrosses back up to tell me that chlorine was a -1. So in this compound, Pb was a +2 and Cl was a -1. This means that Pb lost 2 electrons because plus means to lose and negative means to gain. So that means that the Pb, one of these electrons, or 2 of them, have to be lost. And they go to each chlorine. So if I could just show you visually, one of these electrons would go to the chlorine, boop, and that's a transfer of electrons. It's not sharing. There's no bonds. Pb actually lost it. And then the other one goes to the other chlorine. And do you see how each chlorine gained 1 valence electron, being a -1, and Pb lost 2? And that's how it would be. So Then I could bracket this off and say that this is a +2, and I could bracket each of these off by saying this is a -1. So overall, this whole compound is PbCl2. So now they're saying that all the valence electrons are located on the Cl- ion. But look here, Pb still has 2 valence electrons. That's why this statement is wrong. It's not all of the valence electrons. Pb, lead, is still holding on to 2 valence electrons. So that's what you would have to state. That's the difference there. So this statement is wrong. Not all of the valence electrons are located on the Cl- ion. You could say majority are located on the Cl- ion, but Pb still has 2 valence electrons. And these valence electrons come from the 6s2 subshell if you guys were doing electron configuration, but 2 nonetheless. So that's how we would correct the first part. Now let's look at the next part. They say all, so there's that all again, so that's probably where it's going wrong. All of the valence electrons in the HCl molecule are shared between H and Cl atoms. So let's see. If we drew out HCl, we have hydrogen and we have chlorine. Each hydrogen had 1 valence electron, so I will just put 1 dot for hydrogen. Each chlorine, just like before, had 7, so I will put 7 dots around chlorine. And now you only make a single bond first, and then you check for octet rule, right? That's how we do covalent bonding. So 1 electron from hydrogen, 1 electron from chlorine. They are sharing. That's what this bond is representing. And now hydrogen has 2 electrons. This bond is being shared with hydrogen and with chlorine. So you could count the bond as 2 electrons for hydrogen and 2 electrons for chlorine. So that's fine. And then Cl has 8 electrons, 2, 4, 6, and 8. So that has the octet. And remember, with covalent bonding, hydrogen can only have a max of 2. So even though it can't reach 8, hydrogen is perfectly happy. And chlorine has the octet, so that's good. But now it says over here, all of the valence electrons are shared. Is that true? No. How many electrons are shared? Only 2 electrons are shared. So that's how that statement is incorrect. Only the 2 electrons are shared because we only have 1 single bond. All the other electrons, these 6, are with chlorine exclusively. Hydrogen does not get those electrons. So that's how the second part is incorrect. You could say 2 valence electrons are shared between H and Cl. All right? So that's it, guys. Just take the time and write that down in like a paragraph form because that's probably what they want here. But drawings can't help. So I hope this is understandable for you guys. Let me know in the comments. Thanks for tuning in. I'll see you guys all in the next question. And if you wouldn't mind, please hit subscribe. See you later.